Welcome everyone again, and welcome to our morning briefing presented by the Washington County Chamber of Commerce. I'm Jeff Cachola, president of the Chamber. We're excited this morning to partner with Crown Castle to discuss the future of wireless connectivity. We have all become dependent on our wireless devices, from participating in webinars and virtual events, taking pictures and sharing them with our friends and family, as well as connecting with our loved ones. And while our need for connectivity is going to be increasing over the years, it's predicted in the future that that's going to be 5G. And today we're going to learn more about Crown Castle and how they're making that all possible. We want to encourage your work with us this morning and be as interactive as possible. And I ask if you have any questions, so please use the question and answer feature at the bottom of your screen. Now, please join me for welcoming our partners this morning to Crown Castle. I'm going to introduce Tom Musgrove, Government Affairs Manager, Paul Gilbert, Network Real Estate Manager, Shawn Dugan, RF Engineering Manager, and finally, Renee Morales, Public Affairs Manager. Renee will be moderating our panel discussion this morning. Renee, good morning, and let me have you take it from there.
Thanks, Jeff. Welcome, and thank you all for joining us virtually. We're excited to talk about the future of wireless connectivity. Before we get started, I'd like to thank the Washington County Chamber of Commerce for partnering with us on this event. We're proud to be a member of this great group of businesses. Crown Castle plays a vital role in enabling wireless connectivity, both currently and in the future. Today, we're going to talk about shared communications infrastructure that makes wireless connectivity possible and that will enable the rollout of 5G across Western Pennsylvania and the nation. As Jeff mentioned, please be sure to type your questions in the Q&A box at the bottom of your screen. We'll get to as many of the questions as we can at the end. The continued development and improvement of infrastructure, roads, bridges, water systems, public transportation, is vital to our sustained growth. However, when we consider infrastructure development, we need to start thinking of the space over our heads, not just under our feet. So I want to take us through a few slides and create a foundational understanding of infrastructure. Our investment in Pennsylvania and Western PA. There we go. So first, look, there's a lot of numbers on these slides, but I'm going to call out a few as you look at them. One, our infrastructure across the Commonwealth and in Pittsburgh, who we cover and can cover with the infrastructure. It's almost 100% of the population. Two, in the state of Pennsylvania, we have government, schools, and public safety customers that rely on our fiber, our towers, and small cells for connectivity. And three, over on the Pittsburgh side, are resident employees, but that's just really a small snapshot. One of our biggest offices sits in South Point, and we really consider Canonsburg kind of our backyard. And so we're very hometown proud to be in Washington County and to be connected. We really believe in being woven into the fabric of a community. So next, let's talk about the infrastructure. So first of all, across the nation, we have 40,000 cell towers. So that's what you see off in the horizon. They create coverage in a geographic area. So in Pennsylvania, we have about 2,000. In the city of Pittsburgh, we have about 30. So next, let's go to rooftops. So you can't actually put a big cell tower, 150 to 300 foot tower, and drop it into downtown Pittsburgh. But what you can do is put the same type of equipment on a building, and we call those rooftop installations, so that you can create the coverage of a geographic area while not dropping in a bunch of steel and encumbering the cityscape. So next, let's talk about small cells, because that's what you're going to hear a lot about today, because that is what you're going to hear when you hear about 5G anywhere in the press. Okay, so small cells create capacity. So think about cell towers, the big ones, coverage, small cells, capacity on a network. So we have, as a company, 70,000 small cells, either on air or under contract in the nation. And this is what we're going to hear about most often when we talk about 5G. Now, here's the thing. The thing that's wireless is really your device to either a small cell or a tower. But really, fiber creates the backbone of all data transmission, and that's wired. So everything we do when we talk about 5G, we want it to be ultra high speed and ultra low latency. And thankfully, we have an RF engineer on the panel today, and he's going to talk a little bit more about that. But just remember, fiber is critical, and it's in the ground, and it's the wired part of all the infrastructure. And across the nation, we have 80,000 route miles of fiber. So let's look at a couple of examples of what small cells look like. So up in the, for me, it's the upper left-hand corner, there is a picture of a small cell installation in Oakland. Typically, you'll see these on utility poles, light poles, just different types of installation. These other pictures that you see on the screen, these are across the nation. We like to say they're hidden in plain sight. So maybe before today, you've never even noticed one of these. And maybe after today, you will start to notice them. That's because we've pointed them out to you. So what's driving the change, right? Well, to be quite honest, it's us, right? I think the average household has 13 devices, and we're all doing things on our phones, our wearables, our iPads that we've never done before. 10 years ago, we couldn't expect that we could watch a movie, text our friends, send some emails, maybe even have a phone call all at the same time, right? And in 3 years, we won't be doing what we're doing today. We'll have an expectation level that our phones and our devices will do much more. So the consumers drive demand on what the infrastructure needs to be able to do. Okay, let's look at the economics, because look, this is the Washington County Chamber. We want to know what this is going to do for businesses. Look at these numbers. Look what it's going to do across the nation for GDP, and look at the bottom numbers. These are examples of what it can do in Philly, what it can do in Pittsburgh, and what it can do in towns across the Commonwealth. But what we have to be able to do is deploy quickly. We have to remove roadblocks to get the infrastructure in place. Because really, when we think about different types of industry, different types of businesses, different types of geography, I don't think there's an industry that won't be touched. I think if we look at businesses, so I think the average they say right now is 3 million maybe new jobs. I think the expectation is 800,000 small cells will have to be built to support a 5G network. 20,000 technicians will build that. We're talking lots of jobs in lots of industries. And that's really the exciting part of this. And so if you're a small business owner or you are an employee at a large company, really you can be part of the 5G revolution because it's going to touch everyone at every type of company. Okay, so I hope that provided a really good, just foundational understanding. You don't have to walk away from that and be an expert. I hope it just sparked some interest into knowing more. So now we're going to kind of go a little bit into a deeper dive. So joining me today are some of my colleagues from Crown Castle, and so. So maybe Tom, we could start with you if my guys will introduce themselves, and then we'll get into some Q&A that we know are some good question starters.
Good morning. Thank you, Renee. My name is Tom Musgrove. I'm the Government Affairs Manager for Crown Castle. I work out of our Canonsburg office. I actually also live in Washington County. I've been with Crown Castle for about 7 years. My role is to act as a representative or liaison for Crown Castle with state and local governments. Paul?
Hi, everybody. Good morning. My name is Paul Gilbert. I'm a regional manager of permitting for Crown Castle. My team works with local governments. We pick the sites where we're going to install small cells and then work with communities to get the proper permits and authorizations to install those. Shawn?
Thanks, Paul. My name is Shawn Dugan. I'm the RF manager for Crown Castle. I get it all the time. RF stands for radio frequency. I grew up in Western PA, spent my entire life here. My team is responsible for working with all the wireless carriers and helping them identify areas in their network where they would like to improve, whether it's coverage or capacity. So we work alongside those to make sure that they're able to utilize the assets that we have in place to improve the overall customer's experience. We also another feature of what my team does is we also work on in-building solutions. So for example, PPG Paints Arena where the Pittsburgh Penguins play, we recently upgraded the system there to allow, again, AT&T, Verizon, T-Mobile, the ability to enhance their coverage and capacity so that you can do all those unique features that everyone is looking to do while watching the game. Back to you, Renee.
Thanks, Shawn. Okay, so Tom, before we dig deeper into all of this, we've heard a lot of buzz around 5G, and I touched on it a little bit. Will you just talk us through what is 5G at a high level, and how will it impact businesses?
Yeah, 5G is the next generation of wireless connectivity. It'll take all of Crown Castle's towers, small cells, and fiber in tandem to enable much faster upload and download speeds for connectivity. It'll increase capacity with people utilizing more and more devices, and that will impact multiple industries, education, manufacturing, agriculture. It'll enable connected vehicles, and it'll promote telehealth.
Okay, that's a good foundational understanding. So can you talk to us a little bit more about the difference between 5G and the previous generations of wireless connectivity, which some of us might still be on, 4G, LTE, let's say?
Yeah, and most of us are on an LTE 4G network today. We think about the evolution of all the different Gs. The first G was essentially analog voice device to the device. I think of for anybody who watched the television show Saved by the Bell in the 1980s and early 90s, the gigantic Zach Morris gray phone. And then that evolved into voice and text. So then people had their Nextels and they could text each other. And then that evolved into the 3G network, which was essentially, I think it's always easy to think of the device. So you think of the BlackBerry, and people are starting to email on their BlackBerries. So you have a little bit of data, text, and phone. And then you think of the iPhone and 4G. So that's kind of where we are today. And the amazing innovation that came along with the 4G network, all the applications that we have on our phone, even people that may be watching this webinar today on their phone, the 4G network enabled that. So as we move to 5G, we expect the amount of devices to increase exponentially. So there'll be more connected vehicles, there'll be more devices, wearables, more applications, as I mentioned, through agriculture, telehealth, education, and all these devices will be utilizing tons and tons of data. If we think of, in Pittsburgh, an application like Uber. So they've been doing Uber test vehicles over the past couple of years for the driverless vehicles. A single autonomous vehicle uses 1 exabyte of data per day. Now, exabyte is it's probably something that doesn't resonate with the audience here, but it is equal to 1 million terabytes. And probably maybe about 5 or 6 years ago, we were all using external hard drives with our computers. So it'd be the equivalent of like 1 million of those. So that's 1 car every day. And how do we take all of this information and allow an autonomous vehicle to be able to be reactive? An autonomous vehicle has to have instantaneous reactivity. If somebody walks out in front of an autonomous vehicle, it needs to react immediately. A 5G network will allow that capacity of all that data, the responsiveness of the network, and the speed to deliver that all in tandem due to the fiber and the backhaul associated with it.
Wow, that's amazing. I was thinking about the million thing you just said. So Paul, Tom said it's going to take all of our infrastructure. So the rollout of 5G sounds like it's going to require everything that we have. Can you tell us more about the small cells and then how they work with like the fiber and the cell towers then to enable 5G. Walk us
Sure.
through that.
Sure. So I thought your slides earlier, Renee, did a good job of kind of graphically demonstrating how these all work together. So if you imagine a small cell like Renee showed in Oakland, that antenna is where your phone is connecting wirelessly. But then coming from that antenna down into the ground, right under the sidewalks and streets in Oakland, it's a fiber optic cable. That fiber optic cable takes the signal from the small cell back to a cell tower or a rooftop installation like Renee showed on her slides. And that's the connection for your phone call to the wider wireless network, because those rooftops and towers are much more established and larger connection points to the wider telecommunications network. So you need all three when you're standing next to the Cathedral of Learning trying to make your phone call in Oakland. You need all three of those components to get you to connect. So Renee mentioned that small cells are going to be the underpinning of 5G. So those are all connected via fiber to the towers. So both fiber and small cells are really going to be needed to usher in 5G and all the benefits that we're going to see from that. But they all work together. They all complement each other, essentially.
So Paul, let's just go a step in here. So we know that small cells are coming online, let's say, right? We're all used to seeing all these cell towers, the macro sites, and we're used to that. And now we see where small cells have to begin to be built and constructed in neighborhoods and in, downtowns, let's say. Walk us through kind of the nuts and bolts of what it looks like to really build one and deploy one. That's what we say in the industry, to deploy the small cell infrastructure, and how we work with, communities and municipalities to determine the siting for an actual small cell. I know it's not typically just one, but walk us through what it would look like.
Yeah, so what we start off with is our customer, and our customers for small cells are the major wireless carriers. So those carriers will know that they need additional capacity, or they need more coverage in a very targeted geographic area. So we'll work with them to find the best spot for a small cell. And when we do that, we start factoring in all of the other variables that we need to factor in. The local government's rules and regulations on things, the other utilities that are in the area. So the fiber is a main component of our build, and typically our fiber is on the same utility poles that we see throughout our communities, or in the same conduit underground that other communications infrastructure is in. So there's a lot of coordination between us and the other utilities in the area. And then we also are looking at the vertical infrastructure. The antenna needs to be elevated to be effective. So we look at utility poles, street lights, and things like that to find the best place to provide the optimal capacity or coverage for the customer, but also work with the other utilities and the local government's rules and regulations. So it's kind of a delicate balance of all those factors and where these get cited.
Okay, I think I got it. Okay, so real quick, as a reminder, please be sure to enter any questions you have in the Q&A box at the bottom of your screen. We'd be happy to answer questions towards the end. So Shawn, okay, it looks like we have a process for working with municipalities, and it takes the relationships. But I know that we don't just willy-nilly do this, right? We don't just go out and drop these anywhere. So we have to take into account the wireless connectivity needs of the local businesses and community when determining where to place the small cell. So how does the RF engineering department play a role in determining when small cells are needed, and then where they're actually placed precisely, let's say?
Yep.
Walk us through that.
Yep, sure, Renee. And like I was saying a little earlier, we work very well alongside our wireless carriers. Again, those being AT&T, T-Mobile, Verizon. They have a great knowledge of their network. They know what their existing network looks like, They're measured, when you make a phone call, if a call goes through successfully, that's measured. If it's not, they know that that call didn't go through properly. Or if you're on a call and it drops, we've all had that happen before. We know that information is collected, and they're looking at all that statistical data. We call them KPIs, key performance indicators, and it's a way for them to sort of measure the health of their network. There's some other things that they look at. Again, when we look at coverage, specifically that's where if you look at your phone and you see the number of bars, 4 bars, you got great coverage, 1 or no bars, you're in very weak areas. So that's one aspect when they're looking at it from a coverage is how do they go about improving the coverage of their network in areas where they have current weak spots. And then the capacity point that comes into play, and that's really where you're seeing a lot of these small cells coming into this 5G, and currently they're being used for 4G as well, is looking at it from a where can we improve, for example, the internet connectivity. The throughput is a term that we use a lot. When you're streaming a video and all of a sudden starts getting pixelated, or it starts, the circle starts, pauses, and it's waiting for that information to come. Those are areas that we know that carrier has some throughput issues. And the carriers look at this information and they look at, the assets that we have or areas that they would like to deploy. And working alongside them, we come up with a very good engineering solution, usually in the form of a small cell where we would like to place that to improve, again, the capacity. It ultimately improves coverage. And at the very end, for all the users out there, it improves the overall experience. Thank you.
Yeah, no, that's great, Shawn. That's super helpful to understand. So there's a great question I want to touch on real quick as a follow-up. And I know this can sometimes be a little tricky because it's not just black and white. So what is the average RF signal range for like a small cell rooftop installation and tower? And I know that's not black and white, but talk us through it.
Sure. So and again, if you go back to the late 80s and the early 90s, carriers were putting up 300-foot towers, and maybe, for example, I remember when, the city of Pittsburgh was covering all Allegheny County, and Western PA was covered by 4 sites, 4 towers covering. And then as more and more people came onto the network and started getting cell phones, it created a need to increase the number of towers in the area. One thing that I didn't touch on is spectrum is extremely expensive, and there's very little of it. And the carriers get the spectrum from the FCC usually through an auction, and the auction usually ends up in the billions of dollars. So they have to reuse this spectrum throughout their network. And in order to do that, they have to add, again, through the 80s, through the 90s, more towers to improve the overall, capacity and coverage of the network. So as we move over into the small cell world, with 5G, that's really been the evolution that Tom touched on, was the increase in data usage that is now, requiring the need to have these small cells a little bit closer to the user. Tom also mentioned about autonomous vehicles. Another term that pops up is latency, and that's really just how quickly that information can get back to the system, whatever system is that you're communicating. A simple thing would be a text message. How quickly does that text message make its way to the person that you're connecting to? In autonomous vehicles, you want that decisioning happening to occur very, very quickly, and it needs to have that information to get to that ultimate decision-making process, so it can assist with all the intelligence that is occurring there. I don't know if I touched base. I know I sort of went off there. Did I miss the question?
Yeah, well, I think it's about like the RF like signal
RF. Yep.
And I know that it's tricky because it depends on how many people are by it and
Yep.
Is everybody downloading a Netflix movie or is everybody texting, right?
So yeah, it really comes down to a tower. We're looking at, it's measured in miles for the most part, especially if you get out into rural areas. When you get into urban areas, suburban areas, again, we have, we're looking at rooftops, things like that, existing structures. Now you're talking, maybe a mile, 2 miles, 3 miles. When you start talking small cells, you sort of remove miles and you're starting to talk about feet. and yards. And you're really looking at a very strategic placement where it really is just covering that area. I sort of look at, a small cell is almost similar to a little bit of a Wi-Fi network in your house. You have one, your neighbor has one, the neighbor down the street has one. That's really the same kind of example of utilizing small cells in small, very strategic areas, because again, you want to be able to put those in locations where you're one, handling the most amount of users that it can, which ultimately offloads from the existing tower, what we call macro network. So again, small cell, very small radius, measured really in yards and feet. When we start talking about the existing towers that are out there, you're talking multiple miles depending on the morphology of the area.
Okay, that's great. That answers this, Shawn. Okay, so Tom, I want to switch gears for a minute. We've actually gotten a couple of questions in the Q&A, and we were going to delve into this topic anyway. Let me sum it up real quickly. What are all these obstacles to rolling out 5G? Like, why isn't 5G just all over the Commonwealth, right? Like, why aren't all of our phones saying 5G, and why don't we just see autonomous vehicles just everywhere? Like, walk us through why that isn't happening yet, and how we work with communities and municipalities to try and get there. Kind of walk us through that whole scenario.
Yeah, it's actually a Pennsylvania challenge. Pennsylvania currently lacks legislation and rules needed for it to become a 5G state. It's not a Washington issue. It's not a Pittsburgh issue. It's not a Philadelphia issue. It's a Commonwealth issue. And the challenge is that Pennsylvania has over 2,500 individual municipalities, and they all have their own individual permitting processes to what Paul spoke to before. So if you think, we'll use 2 Washington County communities. I'm here in Chartiers Township. Let's say Chartiers Township has one process, and then you move over to Peters Township and it has a different process. And in Chartiers Township, maybe it takes us 60 days to permit a small cell, but in Peters, it takes us 240 days. And as you're trying to build out a network, that inconsistency makes it challenging. 28 other states have passed standardized small cell legislation that allows it to streamline the process, the fees, and the aesthetic standards of how we site small cells. And if you just simply Google, where T-Mobile, AT&T, and Verizon are building out their 5G networks, you will see that there are limited Pennsylvania cities, and there's no second or third tier cities. So what Crown Castle's been doing over the past couple of years is advocating for legislation that streamlines this build out of small cells. There's currently legislation in the Pennsylvania House of Representatives. It's called House Bill 1400, and we expect a tandem bill in the Senate coming out in the fall, sponsored by Senator Brown, that will kind of help Pennsylvania catch up to these other 28 other states that have all this legislation. And when you start to think about, not only building out the small cells and increasing the connectivity, but you think of the other benefits that come along with that. Pennsylvania is currently one of the states with the highest unemployment during the pandemic. So I think you mentioned earlier, 20,000 tech jobs that come along with building out the 5G network. You think about the economic development that comes along with all the innovation, with all the increased connectivity, with the speed and the capacity of the network. I honestly can't think of an individual infrastructure project backed by private capital that will increase job growth and economic development across the nation like the build out of the 5G network. And Crown Castle is a committed partner to every municipality in the Commonwealth. As I mentioned, or as you mentioned, actually, we have over 1,300 employees that live in this state. We have more employees that live in this state than any other state in the nation. So it's important to make sure that all of our employees are connected and have great jobs. So as you said, we want to be woven into the fabric of the community. Crown Castle wants to work with each and every community, but we understand that Pennsylvania is also falling behind in the build out of small cells comparative to other states and cities.
Thanks, Tom. I think that gives a good understanding, as there are several questions in the Q&A around why don't we have it yet? That's a good understanding. So just for a minute, Paul, I want us to talk, because we do get this question because we're so focused on small cells when it comes to 5G. Will new towers be built to transmit 5G signals, or will existing towers be modified? Like, what happens to the macro towers in the 5G discussion?
We think what you're going to see with towers is that many of them will be upgraded. And when I say upgraded, I mean equipment that's already on the tower will be swapped out or supplemented with 5G. So the sheer number of new towers is not likely that high. It's the small cells that are going to be required. That's the large number of new pieces of infrastructure that are going to be needed. And we're talking in the hundreds of thousands over the next couple of years in small cells. So when you're talking new infrastructure that we see in our communities, it's the small cells that are going to contribute to 5G. Towers, it'll be more of a swapping in and out of equipment that's already on the structures that we see in the community.
So the macro towers don't go away.
Correct. We still need both. They need to complement each other. They all need to work together to bring that widespread capacity and coverage.
Okay, that's helpful. You know, I think we'd be remiss if we didn't talk a little bit, Tom, about how 5G really impacts public safety. So can you just help us to understand for just a minute, what are the benefits to first responders around 5G?
Yeah, absolutely. You know, we talk about connectivity and we think of all the fun applications, the Netflix and FaceTime and all that stuff, but there's a really excellent data point that we have, and across the country, 80% of 911 calls originate from a mobile device. And when you're calling in an emergency, you need a reliable and resilient communication network for firefighters, emergency medical folks, first responders to do their jobs by having that information not only at their hands, but for it to be reliable. You don't want to drop a call during an emergency. So having our infrastructure and effective coverage and capacity allows us to connect with these first responders in emergency situations, and making sure that when that call goes through, it makes it there and it stays there to get the accurate information for our first responders to be safe whenever they're entering an emergency situation. And then I guess to take that maybe a step further, if we think about the 5G network, you know, I'll give you an example of something that I've seen, an innovative solution for firefighters. There's a company out in California that was developing these firefighter headsets that have augmented reality, and it does two things. One, when they're inside of a smoky building, they can see their other firefighters within the building. Additionally, they showed an application where a building permit department was able to upload the architecture of the building so they could see where they were going, even though they really couldn't see where they were going. And then the last part of that was that device could do real-time monitoring of their heart rate and their smoke inhalation. So you're thinking, on a 5G network, that's creating a ton of data. So we've talked about, Shawn talked about throughput, right? That's creating a ton of data that needs to get back and forth very quickly. A 5G network would enable that headset to work effectively, keeping a firefighter safe in the most dire situations.
That's great, Tom. Thank you. There are a few more questions, but I don't want to misspeak. There's a great question in there that would be great. What's the history of Crown Castle? I'll tell you that for those of you who know a little bit of the history of Pittsburgh, we did start in Pittsburgh. The company did, and we just celebrated a big anniversary. We did a big bell reading at the New York Stock Exchange. Before the pandemic hit, we were able to do a big celebration for the company. We appreciate that. Bob Castle started the company. Bob Castle started the company, and then there were, of course, as it always happens, lots of mergers and acquisitions over the years. And so we are proud to say, that's why I say we're hometown proud, Pittsburghers here for the company. But For all the other questions that we're not able to get to, we'll try to look for those and try to get some better answers for you. We appreciate everybody joining us today. Jeff, I think that's where we are. If you want to come back on for us.
Yeah, thank you, Renee. Thank you, panel. Great discussion and participation this morning. We certainly appreciate everything. As you know, we like to say in Washington County that the power to prosper is under our feet. And when we say that, of course, we're referring to the energy industry that's been so impactful here in the county. But it's also clear after today that I think our power to prosper is also above us, and that is quite clear with 5G and increasing connectivity. It's very important, I think, that we consider infrastructure, not only water and sewage and what's below us, but also the increasing need for connectivity in our community and how that will add to our economic development, job growth in Washington County. So we certainly appreciate all of your time this morning. Renee and panel, thank you so much for being with us. And I would also be remiss if I did not take a moment and compliment the Crown Castle team and your entire corporation for both your volunteerism and sharing your resources during this difficult time with COVID-19. I know you've been very instrumental in helping out our local hospitals and first responders. I'd just like to personally thank you on behalf of the Washington County business community for all of your caring during this difficult time that we've been experiencing locally and, of course, domestically. So thank you very much on behalf of the business community for all your volunteerism and sharing your resources. Thank you again to the panel. We certainly appreciate your time this morning. And to you, our participants, we thank you for being with us on our morning briefing. We'll return with our morning briefings in early September, and we have a great fall planned out for you with a lot of fascinating speakers, and we hope you will join us. So on behalf of the Washington County Chamber of Commerce, we wish you a great day and a great business day in Washington County. Thank you.